In the previous video, we looked at resource pool management. In this video, we will cover the vSphere 6 distributed power management, also known as DPM. We will look at the process of implementing and configuring the various parameters for distributed power management. And we will look at many advanced settings that are likely to be of use to you when you implement your virtual data center. So with that, we're going to now shift to our lab. So we are here in the VMware vSphere web client, and we are looking at the packed pub cluster DPM. This is one I created to show you some of the options for distributed power management, which is one of the aspects of resource management in a vSphere environment. As you can see, there are two hosts here, 192.168.0.200 and 192.168.0.201. When I look at the DPM cluster and under services, that is manage, settings, and then vSphere DRS under services, I see that vSphere DRS is turned off. When I edit this and I turn on vSphere DRS, there's an option that's available to me now which is called power management. This is the DPM or the distributed power management capability that's available, and let's take a look at this. Distributed power management uses wake on LAN, IPMI or ILO to power on or put hosts on standby. So wake on LAN is the WOL, IPMI and ILO are two other protocols basically. The HP protocol is ILO. The more standard protocol is IPMI, and the way they actually work is that there's a separate baseboard management controller, a BMS, that is implemented within servers, and even though the server may not be powered on, even if it's connected to the power line, that the BMS will be in operation, and it can be used to change the state of the server. So right now what we have is that power management or DPM is turned off, and vCenter server will not provide power management recommendations. Manual, it will recommend evacuating host virtual machines and so on, and powering the host back on when necessary. So it'll send us recommendations. And automatic would be when the vCenter server will automatically execute power management related recommendations. So what are we talking about here? We're talking about a situation where we can actually define policies, and based on those policies we can say that if there is within a cluster, a DRS cluster, so DRS has to be on and then power management has to be turned on at different automation levels. So we're assuming right now the automatic automation level. When the actual usage of the resources in the cluster is such that individual servers can be put on standby, essentially powered down, and the DRS capability would automatically sense that, DPM would then basically use DRS to evacuate virtual machines from that host that is going to be put on standby, and then once that's done, the host goes into standby. So instead of using, for example, 7 ESXi hosts in a cluster, if the resource requirements are such that only 4 or 5 are required, using distributed power management in conjunction with DRS allows you to actually do that. And then when the DRS algorithms sense that the load on the existing 5 remaining servers that are powered on is reaching and is exceeding thresholds, then DRS will ask distributed power management to power on one server at a time until the cluster is completely balanced and operating within its parameters. So distributed power management works in that manner. Now, just like DRS, there is a DPM threshold as well. So if the slider is in the center, it means that priority 3 or higher recommendations would be applied automatically, because we've said automatic. Priority, if I move the slider to the left, then what happens is only priority 1 recommendations, which are mandatory recommendations, are applied. If I make it aggressive, then even simple suggestions which basically would be all recommendations, priority 1, 2, 3, 4, and 5 would be applied. And of course, just like with the DRS, you can change that in exactly the same way. So we'll just leave that within the middle here. Now, if I press OK, it says one or more hosts have never exited from a standby state or have failed in the last attempt. And so it's recommended to manually test the commands and click OK to enable power management. And so what I'm going to do is, it says go to the host options page to see which hosts need to be tested. So I click OK. Alright, so vSphere DRS is still turned off. So again, I need to enable vSphere DRS. And I'm going to turn on power management here and click on OK. And if I do this, so it took some time for the DRS to be turned on. This is the first time I moved these two within the cluster, so there's some activity that has to be put in place. So that's basically done. As you can see, power management is now on. Now, the next thing to note is to look at each one of these individual servers. So when I click on the .200 server and I go to System and Power Management, I see that there is a place for me to enter the username, the IP address of the baseboard management controller, and its MAC address. So as an example, I would go in here, and for my baseboard management controller, if that happens to be my username and my password, my IP address would be something like 172.20.50.3, and then I will find out by doing an ARP-A, I find out that my BMC MAC address is 0025.909E and DB0D, DB0D. By entering something like this, I provided vCenter the ability to actually send commands down the BMC management interface. I'm going to cancel out of this because my BMC is not operational now, but this is how one would set that up. So once vCenter knows your user ID and password and the BMC IP address and BMC MAC address, they would obviously show up here. The next thing to do is to look at on the hardware, the power management tab there. And in power management, when we click on edit, we can specify whether we always want high performance so that the vCenter, using its capabilities, basically lets the CPU run at the highest possible speed. Balanced means with reduced energy consumption with minimal performance compromise, and the low power means reduced energy consumption at the risk of lower performance. I always leave it at balanced, although I see no reason why we shouldn't use high performance all the time. After all, we've paid for that server and have adequately configured our data center to be able to manage the cooling required for that machine. Anyway, we will do that and move out of this part of it. Now, going back into power management, we see that the technology is the ACPI technology, and ACPI is the Advanced Configuration and Power Interface, and the states that are enabled are the P states and the ACPI C states. Also, what's required is within your BIOS, you need to make sure that you allow the operating system, in this case our hypervisor ESXi, to be able to control the power state of the CPU. So that is also very, very important. So if we go back into the PackPub cluster DPM and look at the vSphere DRS, there are various advanced options that can be set. So really, as we said before, what DPM tries to do is to keep the host utilization within a target range, and the way it works is that DPM evaluates the CPU and the memory utilization for each host in the cluster and tries to keep it within the default range of 45% to 81%. Now, there are two settings that are actually used for this. There is a demand capacity ratio target. So this is the target ratio, and typically it's 63%. And then there is a demand capacity ratio tolerance host, and that by default is 18%. So really 63 minus the tolerance of 18% is 45%, and 63 plus the tolerance of 18% is 81%. And that's how DPM tries to keep the utilization on the hosts. Now, the other thing you don't want to happen is that you should not allow DPM to look at the overall utilization of a server so often that it keeps powering on and powering off that server, or essentially putting it in standby mode and taking it out of standby mode too soon. So there are two other parameters that are actually used. One is called the min, or the minimum powered on CPU capacity, and the minimum powered on memory capacity, and that actually ensures that DPM always will have at least one host running on that cluster. The other ones are the VM demand history secs host on and VM demand history secs host off. Now, all these actually go into what is called advanced options. So let me start entering some of these values in here. So when I click on edit and I go to advanced options and I say add, so demand capacity ratio target is keyed in like this: demand capacity ratio target. By default, it is 63%. What we can do is we can actually change this to something else, and the value that we can enter for this is, instead of 63%, let's make it 70%. The next advanced parameter that one could use for this. So now what we're saying is that the utilization of a server has the target that DPM and DRS will try to meet is 70%. Now there's a tolerance for this, plus and minus, and the tolerance is demand capacity ratio tolerance host, and this is the plus and minus that will apply to this target ratio. So we say it is, say, 15%. So what happens now is that the DPM in conjunction with DRS will basically try and keep for every server the ratio 70 or the utilization as 70 plus 15, which is 85%. So between 85% on the high side and 70 minus 15%, that will be 55% on the low side. So the utilization of the servers in that cluster will be between 55% on the low side and 85% on the high side. Now, by default, the server power on a period is actually 300 seconds, and to power it off is 2400 seconds. So if there is a sudden increase in the load, DPM will wait for at least 5 minutes before it will start powering on new hosts. And the default value for this is called VM demand history secs host on, and the default value is 300 seconds. So once new work starts coming into the cluster, it waits for this period of time in seconds. Default is 300 seconds. We can change it to 360 seconds. So now it will wait for 6 minutes before it decides to initiate a power on of a server that's on standby. And the same thing for powering off as well. And that is called VM demand history secs host off. So if it reaches a threshold, in our case less than 55%, where it it is looking to see if there are other hosts available in the cluster, so it evacuates virtual machines and so on. Of that, assuming that your admission control allows you to do that, what will happen is that it'll start thinking about turning off a host, and that period by default is 40 minutes, which is 2400 seconds. We can make it 50 minutes, which will be 3000 seconds. So now it'll wait for 50 minutes. It'll wait for 50 minutes before it makes a decision to turn a host off and start evacuating, or rather evacuate virtual machines and then turn the host off. Couple of other ones, they're there basically to make sure that at least one host will be kept running. So this is the minimum powered on CPU capacity. It is powered on CPU capacity. This is in megahertz. So if you want to make sure that if you have a cluster of say 7 ESXi hosts and you have a total capacity say of 70 gigahertz, you have the ability to say, to keep at least a few servers up and running. So instead of 70 gigahertz, you might want to say I want to keep at least 50 gigahertz operational. So that will be 50,000, and the same thing for the memory as well, and that is the min powered on mem capacity. Min powered on capacity, and the same thing would be there as well. Again, this is in megabytes. So if you're looking to set it to say 100 gig, this will be 100,000. And that would set that on as a minimum. So you can always be sure that at least there's a minimum number of servers always running, regardless of what the load is. There is another advanced configuration parameter which is called host min uptime secs. As you can probably guess from that, it is the host min uptime secs. This is the number of seconds that a host has to be up and running before DPM comes in and thinks of putting it on standby. So again, it's a way of making sure that DPM doesn't power on and power off things too quickly. So the default I believe is 600 seconds or so. Let's assume it's 600. So that's another parameter that can be used. Some of the other ones are more about how to tune the algorithm that distributed power management uses, so that when it performs its analysis, there is always a cost for placing hosts on standby, because for example virtual machines would have to be evacuated, and then later on when it's powered back on from standby, the virtual machines would have to be moved back in again. So there is some kind of an estimation that's done there to ensure that the best possible performance can be obtained for the cost. And so there are various parameters and tuning parameters basically that would be used. This is obviously available in the VMware documentation. 99.99% of the time this would not be changed without VMware support's approval, and after they have made sure that that is exactly what's needed. So I would probably, in my environment, look at the minimum powered on CPU capacity, the minimum powered on memory capacity, to make sure that because I understand my workload, that much of resource is always available to power my workloads. And then what I would look at would be my demand capacity ratio tolerance and my demand capacity ratio target. So I can set my own targets based on what I believe is correct for my operating environment. Apart from those, the rest can really be left pretty much default unless you have a troubleshooting situation, but surely VMware support would be engaged and they would be best able to advise you. So distributed power management is a tremendously powerful capability. In fact, there was a video some years ago that was shown by VMware where there is an internet site that is running VMware, and while a certain number of servers are on in the cluster at night time, when the actual work starts around 9 o'clock and so on, how the various servers actually start up automatically depending on the workload. That's kind of old because the internet is now global, so basically it's a 24/7 operation, and it's very rarely that you would hit such a decrease in load that it means that you need to power off servers. Now, you may be in a situation financially where you may want to keep your data center costs as humanly low as possible, in which case you would probably consider using DPM. But again, I think demand capacity ratio target, demand capacity ratio tolerance host, the min powered on CPU capacity and the min powered on mem capacity would do the trick, again, like I said, almost all the time. In this section, we covered some key aspects of vSphere 6 resource management. For example, the vFlash pools, the resource pools, and the distributed power management. In the next section, we will cover extensively the various very sophisticated availability solutions that are available in vSphere 6.x. I look forward to seeing you there.